My function is an exponential, which is f of x equals to 2 raised to the power of x, which means y equals to 2 raised to the power of x. Now I have to find its inverse function. The inverse of exponentials is a log. Let's find the inverse of this function. Swap x with y, y with x. And whenever you are trying to find the value of any variable sitting in the power, logs come in handy. You need to use it, solve it using log. So I will say, and what is log? Log means the power, the index, the exponential, or the exponent for that matter, not the exponent, the exponent. That's what log is. And what is the exponent here? The y. So y equals to the word log. In the world of exponential, this 2 is called the base. So the base sits as a very small number, a subscript under log. And what was the answer of that exponential? The x. That is log. So I will now write f inverse of x is log 2. Since logs are an inverse, logs are an inverse of exponentials. So the domain of the exponential becomes the range of the log, and the range of the log becomes the domain of the range of the exponential becomes the domain of the log. Very, very basic stuff. My graph of exponential look like this. My graph of log, if I were to change the color, looks like this. And they are symmetrical to the line y equals to x. Why? Because they are the inverse of each other. Does that make sense? All of you? Yes? Right? So they are bang inverse of each other. And if I were to just nudge your brain, when do you find when do you have the inverse of a particular function? When that function is a one-to-one function. And how do you prove that a function is one-to-one? Horizontal line test. So if this is your exponential function, it passes the horizontal line test. So does your log function as well. Just brushing on the basics of inverse function and when does this exist. Moving forward, another point is f of x is, let us say, 2 raised to the power of x plus 2. I told you that if you got this kind of an exponential function, the y translation acts as the asymptote. So that means y equals to 2 is the asymptote, and this is how your graph is going to look like. Now, if I were to make a log function, so let's say I want to find the inverse of this function. Let's try to find it. So here, this is y equals to 2 raised to power x minus plus 2. Let's swap x and y, and I'll change the color of my pen. I'll say x equals to 2 raised to the power of y plus 2. I'm trying to find the inverse. I take x minus 2 equals to 2 raised to the power of y. Now I need to solve for a variable sitting in the power. So I will say log to the base of 2 for x minus 2 is equal to y. That's the inverse of this function. Now, the most important point in the world of logarithms, see, I'm just summing all of that up, right, in one shot, right? I'm just refreshing your brain, one shot. When you're in the world of your exponential, your y translation acts as the asymptote. In this world, the x translation is your asymptote. So if I were to draw a graph of this logarithmic function, I'll have to look at it. X minus 2 means that I have pushed the log graph 2 units on the right hand side. So this is x equals to 2. And that's how the graph will look like. This is x, this is inverse. So the basic difference while graphing an exponential versus a logarithm is that the way you identify your asymptotes. Your asymptotes are identified by y translations in the exponential world, whereas your asymptotes are identified by your x translations. Is this clear, everyone? Good.